Welcome to the Dreamforce session on using third-party add-ons to build powerful applications. I'm Arif Gersel, Director of Ecosystem Product and Partnerships for Heroku. You may have seen, you may have seen this slide a ton, or you will this week. In my talk, I may cover features that are currently in development. Please make your purchase and adoption decisions on publicly available information only. In today's talk, we'll briefly cover the Heroku platform, Microservices, why we buy or why we build, the Heroku Elements Marketplace, followed by key elements for application composition on Heroku. And then next we'll explore building apps with Heroku add-ons, followed by a small brief demo. And then we'll close out by examining the customer journey. So before I get started, I'd like to know the audience a little bit. How many of you here have never used Heroku? Okay, great. Who here has developed and deployed an application on Heroku? Okay, great. And how many of you have actually used third-party add-ons? A few. How many people here, your boss made you come and you're just trying to figure out why you're sitting in the room? Yeah, all right. What is that Heroku thing that connects with Salesforce? Go figure it out. All right, so we'll set the stage for this talk by just doing a brief overview. So in short, Heroku lets you deploy and manage applications written in multiple languages. To Heroku, an application is a collection of source code written in one of these languages, in addition to framework and some dependency description that instructs our system how to build and run your application. The source code for your application, together with the dependency files, should provide enough information for the platform to build your application and produce something that can be executed. Once it runs locally, it will run on Heroku with a simple git push Heroku master command. For some applications, you may need to explicitly declare what can be executed. You do this in a text file that accompanies your source code, or what we call a proc file. In the proc file, each line declares a process type, which is a named command executed against your app. The Heroku platform uses Git as the primary means for deploying applications. Git is a powerful distributed version control system that many developers use to manage and version their source code. When you create an application on Heroku, it associates a new Git remote, typically named Heroku, with the local Git repository for your application. And as a result, you deploy your code with the familiar command, just a git push to the Heroku remote. You don't need to make many changes to an application in order for it to run on Heroku. As we discussed, one requirement is informing the platform as to which parts of your application are runnable. If you're using an established framework, Heroku can figure it out. So later on in my demo, I'll be using Node.js, and it executes on Heroku by looking at the information in my package.json file. Heroku is a polyglot platform, which means you can build, run, and scale applications in a similar manner across all the supported languages using just the dependencies in the proc file. So on Heroku, once you have an application deployed, you access your app's environment variables with config vars. An application's configuration is everything that is likely to vary between the environments, including the staging, the production, the development environments, etc. This includes backend services such as databases, credentials, or environment variables that provide some specific information to your application. Heroku lets you run your application with a customized configuration. The configuration sits outside of your application code and can be changed independently of it. The configuration is exposed to a running application via the environment variables. In development, we always want to know what's happening in our deployed code. So it's easy to examine the logs across all the platform components in Dynos. Heroku treats logs as streams of time-stamped events and collates the streams of logs produced from all the processes running into the logplex. The logplex is a high-performance, real-time system for log delivery. Logplex automatically collates log entries from all the running dynos of your app, as well as components such as the router, providing a single source of activity. However, for performance reasons, the logplex keeps a limited buffer of log entries. To persist them, you create actions based on events and email notifications. On exceptions, you would use a logging add-on provider. These add-ons tie into the log drains, which is an API for receiving the output from the logplex. So once you've built your app, it runs in a dyno, which is a lightweight, secure, virtualized Unix container that contains your application slug in its file system. Your application's dyno formation is the total number of currently executed dynos divided between the various process types you have scaled. So each dyno gets its own ephemeral file system with a fresh copy of the latest release. Therefore, your application should be stateless. If you need persistent data, you should look at a data add-on for that scenario. As we discussed, the logplex automatically collates the log entries from all the running dynos of your app, so scaling the app involves varying the number of dynos for each process type. So that concludes a brief overview of what Heroku is, right? There will be some links at the end of this presentation, and I suggest that you visit our Dev Center, which has great tutorials and easy-to-consume documentation for building apps on Heroku. One document specifically I would review is Architecting Applications for Heroku, which will give you a further deep dive on the platform. So now that we understand what Heroku is and how to deploy apps, I want to visit the classic debate of whether we build or buy services. In this next section, we'll take a quick look at the evolution of microservices and how they've aided in the rapid development of new solutions. Whenever we're exploring using an add-on, we are deciding to buy services versus building them ourselves. So, should you buy or build microservices? The classic debate. Yes, you are smart enough to build that component, but should you? Depending on the stage of your company and the size of your team, you should understand your cost drivers. This means you will need developers to build and test these microservices. Therefore, the more you build, the more you must maintain. I prefer spending my time implementing innovative experiences on top of my core functionality. Let's not forget that a development projection is just that. It's a projection. It's padded. And there are tons of unknowns that we don't know about. And so I'd rather pad for the unknowns of innovation versus my foundational services. So in this example, let's assume we have 4 developers we need to build a microservice. Each developer makes $100,000 a year, and the project is projected to take us 8 weeks to build and scale this service. So we're looking at a total rough output of around $64,000. Now assume you could purchase a similar service from a third-party provider at a cost of a plan of $1,000 a month. Your build versus buy decision here is made pretty easy. You have $60,000 worth of decision of unknowns versus a $12,000 decision where you might have solid history from a company that provides the service with support and maintenance always covered. I personally will take the $12,000 risk.
That's just 1 year. That's more than that.
Sorry?
If you build an app, you're going to use it more than 1 year.
Yes, but when you're looking at the initial cost of development, right? So, and again, we're talking about core services, and we can save some time to the end, and I'd be happy to have more conversation with you. So there are 3 things to consider when building microservices. The first is the reputation of the provider. For areas that have been around for some time, you want to explore reviews, you want to talk to other developers, you want to get a sense of the testimonials and their experience of using those platforms. Be cautious of the experiences or things that people complain about that might not align to your needs. When it comes to new solutions in the market, you might be an early adopter. So truly understanding your use cases and the services you need, and if any time you can, always try before you buy. Next, you want to understand the support. It's critical to your success. If you run into issues, you want to know how long it's going to take for you to get assistance. For enterprise scenarios, you want to ensure that there's some form of 24/7 lifeline for you. And last but not least, you want to ensure an easy integration into your application architecture. Does the service provide easy tutorials? Is it easy to integrate into your current development stack? So brand reputation, support, ease of integration, these are all important things to keep in mind, and all decisions aren't equal. So you should consider building when the microservice functionality is core to your product or a key value differentiator. You should also consider building if the needs are more complex than a single solution can cover. But don't get bogged down by trying to force square pegs into round holes. A lot of times I see people putting together solutions and then they still have a feature gap. You should consider buying when the needs of the services are not core to the key differentiation value of the product you're bringing to market, or when a provider provides functionality to your product in addition to covering your core needs. Sometimes you get features for free, as we'll see in our demo later. So that's a basic decision framework that I use for when I'm building a product. Am I going to buy? Am I going to build a microservice? I really want to spend my time focusing on the innovation aspect of the things that we're building. So let's take a look at the Heroku Marketplace. There are 3 main types of elements on the Heroku platform. There are build packs, there are buttons, and there are add-ons. Working our way from right to left here, you can navigate our site, and each one has easy-to-navigate categories. Build packs are responsible for transforming deployed code into a slug, which can then be executed on a dyno. Our buttons allow you to deploy apps on Heroku with a one-click operation without leaving a web interface. but our add-ons are specialized value add-on services that can be easily attached to an application extending its functionality. Add-ons exist so developers can focus on their own application logic and not the additional complexity of keeping services running at production capacity. Apps make use of add-ons to provide backing services such as databases, queuing and caching systems, storage, email, and more. These add-ons are provided by Heroku in the first-party context, as well as some of our third-party partners. And currently, our add-on marketplace has over 170 offerings across multiple categories. Heroku treats add-ons as attached resources, which means provisioning the add-on is a matter of choosing one from the marketplace and then attaching it to your application. As we'll explore later, add-ons are installed on the applications using the Heroku dashboard or the command line interface. So now that we've covered how to deploy an app on Heroku and extend its functionality with add-ons, let's explore some of the key elements and categories. Our first-party add-ons, as I mentioned, are built and maintained by Heroku. We have Heroku Postgres, which is a trusted, secure, scalable PostgreSQL database as a service optimized for developers. We have Heroku Redis, which gives you the Redis you love with a more robust developer experience. Heroku Redis lets you gain performance visibility and manage your instances with a powerful CLI. We have Apache Kafka on Heroku, which is a distributed messaging service solution for managing events with the Heroku developer experience. And finally, there's Heroku Connect, which allows you to build Heroku applications that share data with your Salesforce organizations and deployments at scale. In addition to our first-party offerings, there are a ton of third-party offerings from logging to monitoring, security, authorization. As I mentioned, we have over 170 in our marketplace. So if we take a look at a few of these brands that you may recognize, there are data stores, as I mentioned, Heroku Postgres, but there's also MongoDB solutions from MLab or ComposeDB, Heroku Connect, which we just went over. There's application performance monitoring solutions from New Relic or email solutions from SendGrid, as well as error and exception solutions from Rollbar that are all easy to integrate. A new popular category that we're seeing is content management. And so one of our demo I'll use later will leverage Butter CMS, which is a headless CMS image service, which allows me to forego doing things like WordPress or Drupal to bring content really easy into an application and stand things up pretty quickly. There's also search, so we have Elasticsearch or Bonsai Search, and a lot of our categories have multiple vendor offerings. If you look at things like authorization, which I've constantly seen people write apps and deal with the complexity of doing auth, like Auth0, right, and not spend the time worrying about standing up authorization or logging. So let's dig into add-ons and where to find them, okay? So an add-on is a resource attached to your application, as we mentioned earlier. So here's what a developer can do with an add-on. You can install any number of add-ons to an application. You can install multiple instances of the same add-on to the same application in some cases. You can share certain add-ons between multiple applications that have the same owner. And you can log into the add-on dashboard for more actions in a single sign-on experience. There are also actions that add-ons can take on behalf of your application. An add-on can interact with the Heroku application in a few ways, including adding and updating config Vars to the application using the add-on. It can write to logs, and it can also read logs, as well as listen to deploy events and domain add or remove events. Finally, it can view app information and the app owner information. So sometimes you'll see and you'll get marketing campaigns or drip campaigns from add-on providers as you provision their application because they can actually get your information from the application API. Heroku add-ons are primarily installed in two ways, via our dashboard or our CLI. They offer multiple plans that offer multiple features and capabilities. These variables are set and updated by the add-on providers themselves. Add-on plans are usually priced by the month and prorated to the second, so you only pay for what you use. The simplest way to search and install add-ons is via the Elements Marketplace. You access the dashboard on the deployed application, and you can click the Configure Add-ons section. Under the Resources section, you can also see the add-ons attached to your application. If you know the name of the service you would like to provision, you can type it here. Clicking the Find More button will fire up the marketplace so you can conduct a more exhaustive search. But let's assume I want to add a security add-on to the application and ensure things in production are okay. I'm going to add Sneak by typing its name in the input field and pressing Enter. Next, I'm presented with plan options, and almost all add-ons offer a free plan for you to try before you buy or test out the functionality. So I'll quickly explore the other plan options to see if this service fits my need. I can get a sense of what my cost will look like as I project future development needs. After selecting my plan and provisioning the add-on, the resources attached to my app, the config vars have been set, and I can single sign on to the service in the dashboard to explore its functionality. Every add-on provider implements their own portal. However, you can easily get back to your application dashboard by using the top-level Heroku bar, as indicated by the arrow. So as we discussed, once provisioned, add-ons are available as config vars on Heroku. A config var provides your application with the information on how to access that service. Because add-ons have access to config vars within your application, they can change them in some cases at any time. So if there's an error on a service, if an add-on provider has a failure in their infrastructure and they need to switch over services, they can update your config var. We also have instances where we have some of our email providers may notice abuse of their services, and so on their end, they can roll your creds and cut you out of their service if they notice your application is participating in spamming or phishing attacks, things of that nature. So it's important that you don't hard code or cache your config vars. They're meant to be dynamic. So how do you find your config vars? You access your config vars by going to the settings section. You will see on the settings section, reveal config vars just below. Once you reveal your config vars, you can edit them or delete them, and you also have an opportunity to add new config vars here. And again, this can be done via the dashboard or the CLI. Via the CLI, you have a lot more control over your add-on provisioning. You can install an add-on using the Heroku Add-ons Create Service command, which will provision the add-on with its provider. It'll give an add-on a global name. It will give you a default alias to your application, and it will set any config vars on the add-on provides using names based on its alias. This example provisions the Heroku Edis add-on and installs a hypothetical app important app. When we build upon this example further, we'll build upon the example further to show you the functionality via the CLI. To explore add-on details, you use the Heroku Add-ons command. The resources section lists the add-ons that are owned by the application. It includes relevant details about the add-on, such as its plan, its global name, and its cost. The attachment section lists all the add-ons that are attached to this application, more specifically have an alias to an add-on. It's important to note that regardless of whether it's owned or not. This is where we can see that Redis is an alias to our Shining Calmly 4402 add-on we just installed. Right now, the distinction between the add-on resource and its attachment may seem unnecessary, but we'll explore this further to show why it's important. There are a few ways you can finally control how add-ons are associated by applications. By default, an add-on resource is given a haiku name, such as Shining Calmly 4402. However, you can custom name an add-on, and some add-ons can have multiple names within an app. For even greater flexibility, some add-ons can be attached to multiple apps. Therefore, it's important to use meaningful names. The global name for our add-on, Shining Calmly 442, even though it's calming, isn't quite meaningful. Choosing a meaningful name can be crucial as your application grows in its complexity. We can give an add-on a meaningful name when it's initially created by using the name option as highlighted in this example. Now, wherever the add-on instance is identified, it will have a recognizable name. In this case, the name is important Redis when it is referenced in the resources and attachment details of important app. Remember, if the name of the alias is important and relevant to the application, consider setting it yourself. Not all add-ons support choosing your own alias. Alias naming conventions must also conform to the same conventions as config vars, which means they must begin with a letter and only contain alphanumeric characters and underscores. We can use the same Heroku Redis instance as a session store in addition to a task queue broker. We can achieve this with Heroku Add-ons Attach, existing add-on command. This links an add-on to an app with a new alias. We see the extra alias, Heroku Add-ons, and the new config vars added with the Heroku config in this example. The attachments link to the same important Redis add-on and have the same config var values. The manner in which you create multiple aliases is also how you rename an alias and its corresponding config vars. This is done by creating a second attachment and then removing the original one with Heroku's add-ons detach attachment name. So suppose the tasks that we're queuing to our broker need to be processed by a different component in a different application named important tasker. We can share the add-on on the second application using any alias we like or the default. Here, we'll reuse the meaningful name broker so that we understand its purpose in the future. Using the Heroku add-ons attach command, you can share an add-on between apps. In the example shown, we are attaching the important Redis add-on to our important tasker app with the alias broker. Let's look at the add-ons config vars on the second application important tasker. There are no add-on resources owned by the important tasker application. However, it does have an attachment named broker to the add-on named important Redis. It's important to note here that the billing is handled by the important app application, because that's the original app that this add-on is attached to as a resource. The broker URL shares a value with its kin on important app. So if an add-on provider changes this, both apps would automatically restart with these new values. Most add-ons are designed to be installed just once on any given application, but some add-ons can be installed multiple times. For example, suppose we want to have our task broker and our session store backed by different instances of Redis. We might want to do this for a number of reasons, such as limiting what data is accessible when we share an add-on. As you can see in the example, we can create a second or even third instance of a Heroku Redis add-on. By using the Heroku add-ons attach command, we can replace the session store alias with one pointed to our new add-on. Notice that session store, broker, and Heroku Redis rows each point to a different add-on instance. Each have unique values set to their corresponding config vars as well. Since the add-on alias as Heroku Redis store was just created as an example, and the Redis alias is redundant in our scenario, we can remove them. By using the Heroku's add-ons detach command, we remove the Redis attachment Siley Nobly 1891 from important app. By clicking the Heroku add-ons destroy command, we remove or deprovision the cooling carefully 7273 Redis add-on from important app. Note, add-ons detach command removed an attachment alias Redis, while add-ons destroy deprovision the add-on, as well as any associated attachments. Now everything looks the way we want with two distinctive instances. One is which is alias is broker to both of our applications. So there are a lot of things that you can do with add-ons here, and I was taking you into a deep, advanced use of our CLI here. So we'll pick up the pace and go more into a GUI and actually look at some of our experience, but you should play around with add-ons. As I mentioned, there's great documentation on our Dev Center. There'll be some links to this slide, and so please follow up in the future and do some cool things like share a message queue between applications, or replace a Redis Cloud instance with a Heroku Redis instance, vice versa, via aliases. It really doesn't matter where you swap out the backend services if you're focused on your aliases and your config vars. So let's take a look at some add-ons in action with a demo. I'll build a simple web app using some Heroku add-ons here for some of the core functionality. So like many Salesforce employees, I volunteer in my off time. One of the things that I volunteer for is a nonprofit organization that is opening a co-working space. So as the sole board member who's technical, I usually get all of the work to go do. And so one of the things that they want to go do now is launch a new co-working space site, which will drive memberships and engagement and things of that nature. So in this solution, you'll see this is the design I just finished a few days ago, and I'm going to start stubbing this out here live. And the goal really is to use some of our add-on providers, specifically Butter CMS, to provide some of this content, specifically around things like events. When you look at testimonials or this team section, these are all the kind of dynamic content things that I don't want to go back as a developer and constantly update, but I also don't want to stand up a WordPress or a Drupal solution just to have a content management system to feed things into my Node application. And then ultimately, there's a blog aspect here that content management systems were perfect for blog. So let's dig into this a little bit here. Let me see if I can switch out. All right. guys see that there? It's pretty good. All right, I can't see. There we go. All right. So the first thing I'm going to do here is I'm going to open this Heroku application. Click Heroku open, which fired up another screen for me. Get this here. Sorry, I am monitoring my mirrors, and what I'm going to do now is I'm just going to take my mirroring off for a second. I'm going to mirror my display so we're all in the same thing. Okay. Perfect. All right, so here's an application that I deployed earlier today. The union.io is the website. As we can see here, I've already attached a few add-ons, Butter CMS. I attached a PostgreSDB. I have a MongoDB solution. So I'll go and single sign on into the MongoDB solution and pray that the demo gods are working on our behalf, which they are. And as we can see here, I have a couple of tables, some user accounts that are already in here. So I set up one user account and a second user account earlier. And as we can see, I single sign on right into this add-on service provider and can start handling the resources. When I look at Butter CMS, which is going to drive most of our content, I can also single sign on into their dashboard. As you see here, here is the API key that I need for this service. And if I go back over into the application and go into the settings and do reveal config vars, you'll see a bunch of my config vars are revealed here, and specifically the API key for the Butter service. So let's head over to my code. So one of the things that I've done here is I've deployed a Node application, pretty bare bones right now. But what I've stubbed out is some areas where we can see here where I'll actually be using the SendGrid. I'm using Mailgun here as an email provider. So I actually don't have that set up right now on my application. If I go back to my resources, I don't have Mailgun set up. So let me go ahead and provision this resource. So there's Mailgun. I could also do this from the CLI. I'm just going to do their free plan to get started. All right. So Mailgun has been set up. If I click this and single sign on into their dashboard experience, I pretty much have a sandbox ready to go to start with some email delivery. I'm going to go down here to my sandbox domain, and I'm going to add an account as an authorized recipient so I can show our email exchange here. So let me add contact at the union.io. Okay, have that correct? All right, let me go over to my Gmail. All right, let's see if we get a new mail here. All right, there we go. So Mailgun is asking me if I want to use this account as a verified test account, and I'll go ahead and give it permission. All right, now that I've done that, let's go back to my solution. And so what we can see here is in this contact page, I'm using a Node mailer module in Node to set up the Mailgun service here. And I'm basically accessing the config vars. So Mailgun login and the password config vars that we can also see here to drive this service. And so now that we just spun up Mailgun, we can now see these config vars have been added to our application. Let's go over to the home, and I'll go to the contact page. So Arif is my name. There's my email address. And using add-ons live is dope. Send off that email. All right, it says your email has been sent successfully. If I go back over here, I see I have a new mail from this contact form. Using add-ons live is dope. All right, that's great. So we have mail working. If I want to go back over here to my dashboard, so now we also have the content management system. If we look at this front page, we'll go back to home. We see things are pretty empty. what I've done, if I go to my home page, is I actually have an area here that has some conditional code that will start to show blog entries if they show up. This same code is being driven by this API call here that is basically using Butter. The API key for Butter, again, is stored as an environment variable. I'm asking Butter to give me all of the blog posts that it has currently and save it in blog data, and then I'm passing that blog data back as a response to my web application. If there is data, basically what we're saying is for every blog that's in that data, I want you to print out the title, the summary, and who the author information is. So right now, we don't see anything there, so let's go ahead and create a blog. So I'm gonna go back over here into Butter, do a blog post. There are no blog posts, I'll write one. And just to make this quick, I've saved a blog post here. So I'll grab a title really quick. Let's see, we have some Lauren Ipsum. All right, we got some categories. I'll just pick some recent ones: conferences, education, another quick summary of something. Let's grab an image, pick the computer. All right, switch over to SEO. Let's give this an SEO friendly title. Hi, it's me. Someone made a suggestion. I'm just gonna fill this in. And so let's publish this blog post. All right, so now that blog post is published, hopefully we'll see that just get pulled in here to our application. It may take a second for us to get this, but if the demo gods are smiling upon us, we should be able to pull this content in. While we're waiting for that, let me go add a second post. And I'll just use some dummy data that we already have here. Okay, write a new post. Number 2, blah, blah. Give it a summary. Let's use a Dreamforce image. SEO friendly title. And let's publish that blog post as well. Dreamforce rocks, since we have some title clashes. All right, so as you see, we were able to quickly add blog posts and bring in content into this web app without having to build or maintain our own blogging or content management system. For me, this is super important. I don't want to spend time managing content management systems or other things. Just having an easy way where I could turn this back over to my marketing team to log in and update content is great. Let's go back here. All right. So basically, there are other enterprise features you can look at. That's a very simple application, using a small web app and a little bit of time, pulling in some services. But really, you can build enterprise solutions with enterprise-level add-ons. Our team accounts allow groups of people to collaborate on application development and manage billing in a single location. With various levels of controls, admins can restrict team members to certain add-ons through what we have called whitelisting features. So you can say, I prefer you to use SendGrid versus the Mailgun add-on. You can actually restrict your team to add-ons based on compliance or other needs you may have in your organization. With review apps, you can also easily spin up temporary apps to review new code. These ephemeral apps have add-ons provisioned for short-term use that can mirror your production environment. Many of the add-on providers in this case, though, do offer their ephemeral plans at some cost, which helps them cover the infrastructure from constant churn of those applications. So you should always note that even though you may be using a free add-on, if you spin up an ephemeral app, there's an opportunity that you may be charged for it. Last but not least, I wanted to just walk through a typical customer journey. So what we see here is a real customer from 2014 and their add-on journey. And you can see they started with only a couple of add-ons, right? And so as you build your solution, you may think about things that you want to do later on, but you don't have to do them all in the first day. So for me, working on this application that I'm doing for this nonprofit, I actually know it's going to connect to a Salesforce instance later. So I've already added Heroku Connect and a Heroku Postgres database. So when new members sign up, we can actually feed those leads from the website into the Salesforce instance. Also looking at things like login and security. So as your needs grow, the application landscape and add-on landscape can also grow with you. So here are some additional links to the talk. As I mentioned, visit Dev Center. A lot of great information there on how to build and architect apps for Heroku. I'll leave this up for a minute. Also read the 12-Factor app. It's a great read. It's a methodology for building SaaS applications. And then last but not least, one of my partners, Butter CMS, who we just demonstrated some of their functionality, actually spearheaded this ebook that they recently deployed called Microservices for Startups. And the cool thing is I have about 10 to 20 add-on partners who have contributed to various chapters here, so it isn't just written from the perspective of one company, but it's a great text on microservices for startups and dives deeper into some of the decision points that we covered today. There are other related Dreamforce talks. I know things are just getting started. There's a microservices event architecture, an Apache Kafka talk on Heroku that would be super interested. These are some of the things that I'm personally going to geek out and go watch. Manipulating and integrating Salesforce data with Heroku Connect and Postgres is really interesting, especially as you start to think about the power of Salesforce and Heroku together and how do you bring these development clouds together to drive customer experiences and sales experiences. How we built scalable microservices based on a Heroku app is another great talk. And then finally, deliver, scale, and manage apps, a tour of Heroku. This is just a subset of talks. These are some talks that I pulled out of the schedule that I think are relevant based on your interest maybe here today. So I advise you to explore other things and also stop by the Heroku booth in the pavilion and get some demos for some of our functionality. So with that, thank you for your time. I appreciate it. Take any questions anyone may have at the time. Sorry. Okay. No questions. All right. Thank you very much.